Hello and welcome to this webinar on JSON. My name is Keith Donaldson and I'm the Director of Business Development. I work out of the Trihedral UK office based in Aberdeen in Scotland. This is the second in the series of webinars on connectivity. The first one was given by my colleague Blair Sully out of the Houston office in Texas. You can find that available for download on our website. This particular presentation is going to focus on JSON. We're going to take a look at the very brief history. We'll look at exactly what JSON consists of, and then we'll take some practical examples looking at how we can use the JSON driver within VTScada to acquire data. So without further ado, I'm going to minimize this web camera to maximize the amount of desktop space available to us, and we'll continue with the presentation. So let us take a look at the history of JSON. It was originally specified in the early 2000s by Douglas Crockford, and he was trying to find a lighter weight, simpler alternative to the extensible markup language XML. In July 2006, Crockford specified the format officially as RFC 4627 and then further refined that in RFC 8259 and the ECMA 404 standards. Now, lots of numbers there, but the takeaway from that should be that this is a really well-defined, well-documented structure that is used in industry and is well understood. So, what exactly is JSON? Well, it's an acronym, and JSON stands for JavaScript Object Notation. So this is an open standard syntax for storing and exchanging information. It is in a human readable text format, which means that you can actually see and make sense of JSON information. In SCADA systems, or indeed in many systems that use JSON, it is used to send data to and from each other, to exchange information. So specifically in SCADA systems, we tend to use this to exchange data with field devices or other services or servers that provide information. So looking at the acronym, the JavaScript portion of JSON, the reason that it is called JavaScript Object Notation is it was derived from the JavaScript programming language. And although it's derived from JavaScript, it is actually programming language independent. And indeed, many programming languages now support JSON natively, including VTScada script and VTScada. The object notation part is actually really quite important, and it's worth taking a little moment to understand what that means. So in a programming language, we often hold information in memory as objects. So for example, we might have an object that represents a pump, and that pump may have information associated with it. For example, it may have the number of starts, the number of stops, the run time. It may contain information such as the RPM of the pump, how fast it's turning. There may be flows associated with that object, and so on. And we hold this collectively grouped together in memory as a programming language object. The object notation allows us to take that in-memory object and serialize that into a human-readable format that allows us to write it to disk or to be able to hand it off from one system to another, able to exchange that information in a way that both systems, the sender and the receiver, understand what the actual information contained within the JSON format actually is and how it can be interpreted. So that really summarizes what JSON is. You can see on the screen there I've given an example of JSON in the top where I have an employee's object, and you can see that there are three instances there, first name John, last name Doe, first name Anna and last name Smith, and first name Peter, last name Jones. So that would be a representation of 3 employees of a company holding their first and last name. And then below, what I've done is I've taken a little snippet from our source debugger, so that's VTScada's inbuilt source debugger, to show how that information, once read in by a programming language, is actually directly related, directly implemented right there in the programming language. So you can see that we have a structure called a dictionary, which holds an array of 2 elements. Within that it holds the employees, sorry, I should say 3 elements there. The array employees, it holds element 0, which has John and Doe, which are first and last name characteristics, and within that dictionary of 2 elements. The second dictionary of 2 elements holding Anna Smith, and the third holding Peter Jones. So directly you can see the relationship between the JSON serialized text file and the in-memory representation of the programming language. So that's all fine. Let's have a look at what JSON actually is. So in the very simplest form, it's a name and value pair. So you can see here, I've given an example, name Keith, my name. And so that it represents a name value pair. And let's break that down even further. So the name value pair has a name, which is in double quotes, surrounded by double quotes, followed by a colon, followed by some value. And in this case, I've got the value Keith. I've just noticed that the font of the quotation marks around Keith seems to have been changed by PowerPoint, but nonetheless, it is simply just double quotation marks. And JSON can hold a number of valid data types as the value portion. So I've run through each of these and given an example too. So that, again, the first example there, a string. So we've got name, the name as the name item, and the value is a string of 5 characters, KEITH. And then the next one that we can hold is a number, a numeric value. So here I've got age, and then my absolutely true, honestly, age of 21. The next thing that JSON can hold is an object. And when we say an object, what we actually mean there is another JSON object. So I've given an example here where we've got the name item as pets, and then the value item of pets is a JSON string itself, where I've got an item dog and the name Belle, and a name cat, and an item Lucky, my pets. We can also hold things like an array. So an array of element items. So in this example here, I have the name item is hobbies, and then it's followed by a colon, and then you can see it's surrounded by square brackets. We have 3 elements in this array: electronics, pinball, and scouting. The next data item is a boolean, which represents either a true value or a false value. So you can see here, married is true, and my wife will be delighted that I got that right. And then the last item you can set to a null string, which means it has no value, it has not been set. So handsome, and I'll let others decide for me on that. So that is all of the way that, that's all the data that can be represented by JSON. So you might be sitting there thinking, well, why use JSON? There are many different other options for transferring data between systems, binary information, and there's plain text and CSV and XML. So let's have a look at some of the reasons. Well, as JSON is text, it can really be easily sent to and from servers. Sending a text string, string of characters is a really simple way of doing that. It is easily converted, as we looked at on the previous screen, into programming objects. So once you have the information in a JSON file, it is a reasonably trivial exercise to get that from the file into memory where it can be used by whatever programming language or system you're using. In the same way, or the converse to that, it's very easy to take an in-memory structure, something that's been built up by a programming language or a SCADA system, or take that object and persist it to disk for storage so that you can actually hold that information on disk. So now many machine-to-machine interfaces support JSON, and it's a very common way of publishing data, especially across the internet. And it allows exchange of data from a web server to another web server or another back office system. Because of the fact it is nice and simple with just a very simple and restricted set of data pair value pairs, it is very easy to use. So you find that they're very quick implementations, very easy to get something up and running. And it's now becoming the protocol of choice for these terms that you'll hear: IoT, Internet of Things, and the IIoT, the Industrial Internet of Things, because of the simplicity in being able to exchange information. So typically at the moment we use HTTP, so that's the Hypertext Transfer Protocol, to exchange JSON data. But you'll maybe be familiar with MQTT, or Message Queue Telemetry Transfer Protocol. And an MQTT is a method of transferring data from one system to another, again very, very popular in IoT and IIoT. And JSON data is usually the payload that is transferred by MQTT, so you have data value pairs that are transferred within the body of MQTT. But why use JSON and not XML? Because XML has been around for longer, and it is a very well established format. Well, let's take a look at the similarities first. So both can be used for sending data to and from servers or between systems. Both are self-describing. That means that you can look at a file and understand exactly what is within the contents of that file. Both are hierarchical, so they both possess the ability to nest the structures to create hierarchies with them. And both can be parsed by VTScada and indeed lots of other programming languages. However, there are some real advantages to JSON. JSON is shorter, so it is less verbose, and it uses less memory or disk space, so it's much more efficient in those respects. And because it's smaller, it's therefore quicker. It's quicker to read it, to write it, to parse it, to send and to receive it. It's because it's smaller, it's more efficient. JSON can use arrays. It's something that XML can't without having to go into detailed structure development. The JSON data model is a map. So that means that it matches exactly your objects that you have in memory, where XML is very much based around a tree hierarchical structure. JSON structure is really intuitive. It's really easy to map real-world things to JSON. So very simple and very straightforward to do. Whereas XML is much more verbose, and you have to go through the hoops to make that actually work and match your data. And XML is much more difficult to parse. It uses the XML document object model to loop through the XML. So you have a reference and a reference file which you use to parse the actual document file. And that becomes complicated. And there are certainly places where XML should be used. But for the majority of the things that we are seeing now, we're tending to find that JSON is the object model of choice. So just to give you a little practical example, I've just done expanded our little employees database, if you like. And here I've got two examples, one which is written in JSON and one that's written directly in XML. So you can see that we've got three employees just recording an ID, a first name, a last name, and their current age. So you can see on the left hand side the total amount is 350 characters, whereas to store exactly the same information within XML we have to use 526 characters. And I think you'll agree, although it's a little bit subjective, that the JSON is actually easier on the eye and easier to read. And we haven't even stylized or colorized the text here. This is just plain raw code. So I'm going to move now on to a practical example, or two practical examples. The first one, we're going to retrieve the time of sunrise and sunset. So we will provide our location in latitude and longitude, and we'll retrieve back a string of the sunrise, when the sun will rise, and when the sun will set today. And other information is available. This is provided by sunrisesunset.org. Please do, if you're looking at this, take a look at their terms of use. They do make it freely available, but they do like recognition of their service. And then the second one, a little bit of fun, but wanted to show some more real-time style data transfer. So we're going to take a look at the position of the International Space Station, which is updated roughly every 5 seconds. Again, it's going to provide us a latitude and longitude of where the station is, and I'll show you how we can plot that in VTScada. And again, this is provided by a third party, opennotify.org. And again, I'd welcome you to take a look at their terms of use just to make sure that you don't overload their servers. So what I'm going to do here is switch to live demonstration. So I'm going to bring up VTScada here, and we're going to create all of this from scratch. So go ahead and going to add a new application, quick add to VTScada, and start the application. Now I should point out that we do have VTScada Lite available on our website for download. That's free for 50 tags for you, so you can actually try these examples for yourself and download the application and then go ahead and configure it up, and you'll see just how straightforward it is to connect to a JSON interface within VTScada. So the first thing I'm going to do is go to our tag browser, and we're going to create a new JSON driver. So click on the new button. I'm going to select our driver type, so you can see this is a list of all the drivers that ship directly with VTScada, and I'm going to select the JSON XML driver. As it happens, it's the same driver that we use for retrieval of JSON as we do for XML. So I'm going to give this a name, sunrise and sunset. So you can fill in the usual fields within a VTScada tag, the area for area filtering, the description, JSON driver for sunrise, sunset data. And then on the settings tab here, this is where we put in the URL of the website that we're wanting to connect to retrieve this information. So this is we're using HTTP to request this JSON information. So I'm just going to paste that URL into the section here. So the API is actually detailed on sunrisesunset.org, but we can pass in two parameters. The latitude, so you can see my latitude here is 57.18, and longitude is -210. And just to show you, if I bring up web browser and simply paste that URL into the address bar there, you can see that we get returned back a JSON string, and that's the information that we're going to use within VTScada. So I'm just going to minimize that, back to VTScada. I don't need to provide a username or password because this is an open API. It's not using any authentication at all. As you saw there, I can simply make the request and get the data returned back. Got various other things, so we can say I don't need to poll this once a minute because it's not the sunrise and sunset. It's not going to change, so I'm going to change that 86400 just so that I get a poll once a day, polling interval in seconds. We can also, on the extra headers tab, provide extra HTTP headers that are required for accessing the service. So this might be where, for example, OAuth is used. So we do not have a way within VTScada of generating the OAuth key, but we can provide the OAuth key in the HTTP header by specifying whatever the X type or header, HTTP header type is in there and the value. For the moment, we're going to leave all of this at default. We don't need anything more than that. And click OK. And you can see that my sunrise and sunset tags is created there. So now I'm going to create a child. I'm just going to right click onto there and say we're going to create a new child tag, and I'm going to, in this particular type, use a string type because I know that the information that we're getting back is a text string. So I simply want to display this on the screen. I don't need to do any number conversions or anything. So I'm going to create a string IO tag, and I'm going to say this is the sunrise. So there. And I'm just going to leave everything at the defaults here at the moment. Onto the IO tab. Now you'll notice that because I created this as a child of my JSON driver, it's automatically picked up that the JSON driver is my IO device. And we have this really useful address assist. So instead of trying to remember what the path to the piece of information I want to read, I simply just click on the JSON button, and we get presented with the data that was returned from sunrisesunset.org, and you can see sunrise is one of the data items. There's some other interesting information here. So the day length, we're going to get 16, just almost 17 hours of daylight today. The sun rose at 3:48 a.m. and it will be setting about 8:30 p.m. today. So, but we're interested in sunrise, so I simply select that, click OK, and now that will go ahead and create my tag, and you can see that the value field there has been filled with the sunrise. Now I'm going to very quickly create my sunset, so I'll just copy and then paste in here as a new child, and just do sunset, and in there, and the only other thing I need to do is now change the IO address. So instead of results.sunrise, it's actually going to be sunset, but I'm going to use the picker just to make sure that everything's all good there. Click OK, and you can see that we now update there. So this means I'm now able to go ahead and draw these things on the screen in the Idea Studio. So I'll just close that for the moment, switch to the Idea Studio editing. It presents us with the overview page. I'm going to get rid of everything with the exception of our VTScada logo, which I'd like to leave on there. Move that up to the corner. And now I'm going to go to the tag browser, find sunrise, click draw, and one of the things that's listed as simple draw text, so I can just drop that on there. And I can do exactly the same thing with sunset. Drop it on there. And now we have text strings representing when sunrise and sunset that will automatically update when that changes. There's presented on the screen. So that's great. That's one working example. I mentioned we were going to take a look at a different example with some more live data. You can see that the sunrise and sunset's pretty static for each day. So I'm going to go ahead back to our tag browser again, and create a new JSON XML driver, and this time I'm going to call it the ISS, the International Space Station, and JSON driver for ISS position. So I need to go to the settings tab. So as you can see, the URL will have to change. So again, I've got a URL here that I can just cut and paste in. So that's using the opennotify.org, and the URL is iss-now.json. Again, I don't need to specify username or password, but I am going to put the polling interval down to 5 seconds. So this means that every 5 seconds we're going to go off, make that HTTP request, receive back the JSON packet, and parse that into VTScada. Everything else will remain exactly the same. So go ahead and create that. So you can see it's now created my driver here. I'm going to now create a child tag again. And this time we want to read the latitude and longitude, and we want that as a numeric value. We actually want to be able to manipulate that within VTScada. So I'm going to create an analog status here, and I'm going to just call it lat for speed. Click onto my I/O tab again. It's picked up the JSON driver, and we can go into the address assist here, and it now presents a couple of bits of information that's been returned from the website there. So the first is the you can see a message success message, just to say that yes, it was a successful update. You can see the timestamp, so that looks like one of the Unix timestamps with the epoch of midnight 1970, and then you can see the latitude and longitude. So we're going to just grab that just now, click on OK. One other thing that I need to do with the analog is turn off the scaling. We don't really want this value to be scaled, we just want to use the value that has been directly returned from the JSON, so we don't want to rescale that. So I'm going to just simply set the unscaled process min and max the same as the scaled process min and max, and that has the result of just allowing us to see exactly what's returned back. If I click OK, it'll go ahead and create that child, and you can see that the position currently is 40.5. In fact, it's just updated to 40.7. Again, just very quickly copy and paste this for the longitude. Go and change the IO to longitude, and everything else should jump in there. So fantastic. So now we've got some real-time data. Again, we can go ahead and draw this on the screen just by clicking draw, and we can do some simple components there just to represent those. But that's not brilliantly interesting. So it would be nice to overplot that information onto our built-in slipping maps. So if I go to Tag Browser, what I'm going to do is create a context object to represent the International Space Station. So a context is really just like a container, just it's going to hold information about the ISS. So I'm going to create here ISS, and I'll just call this tag Space Station. And I'm going to leave everything else the same for the moment. I'm going to add the site properties, because one of the things that our site properties contains is a latitude and longitude that allows us to specify exactly where a site is located, so that we can drop a pin on a map. And we'll use that feature to display the actual real-time position of the space station. So I'll click latitude. I'm going to use the tag, the latitude tag that we created as the latitude, and then again I'm going to click on tag there and select the longitude there for the space station. Now what we need to do here is probably set our map zoom level to be quite far out. Otherwise we're going to be so zoomed in we probably won't be able to see whereabout on the map the space station actually is. So I'm going to go ahead and create that. So that's created it there nicely. So if we close the tag browser and go to our sites page, we should see the space station there, and if I click onto it and bring up the map, I obviously haven't zoomed out far enough on my map level detail, so I will do that just now. And you can see that it's yeah, just heading north of Japan at the moment. And I guess if we watch it, you can see it just update there. So one final thing that we can do, although it's nice to have a green pin on the map there, it'd be nice to put our own little icon of the space station floating around there. So I'm going to go ahead and create very quickly a tag widget and say that I'm going to be able to draw, because I haven't created a tag type for the space station, I'm just going to say I'm going to render a context for this widget, and I'm going to call it ISS icon. And then I have, hopefully to hand, a little icon that we can pop in here. So just import this little graphic, get rid of our little marker. So we probably don't want this to be too big. So if we represent something like that, perhaps, that's lovely. And then if I just open the properties of our space station and say, actually, instead of using the default map icon, we're going to see if I can select the ISS icon. And now you can see that we have the International Space Station floating over a map of the world within VTScada, and the information provided by JSON. So that really covers everything that I wanted to cover on this webinar. I will now pass it over to any questions. Once again, thank you for attending, and I hope you found this useful.